Today we're going to talk about probability. Okay. Um, you may have done some basics of probability in your courses before, but we're going to kind of just start from scratch. So first thing we want to talk about is what exactly is probability. Probability is the likelihood of an event occurring. Okay, so just the likelihood that an event occurs. The way that we calculate probability is we take the number of ways an event can occur, and we divide it by the number of possible outcomes. Okay, and again, that's that everything is different for different problems. So take flipping a coin. You only have two possible outcomes. You could get heads or tails. Okay. If you're rolling dice, okay, if you're only rolling one, if you're rolling a die, then you have six possible outcomes because there are six sides that it could land on. So it really depends on the situation as far as the number of possible outcomes. And another, just a terminology thing, your sample space, if we ever refer to that, is all your possible outcomes. Okay. So sample space is all of your possible outcomes. Now, we're going to start taking a look at just some basics, basic probability problems. We're going to calculate some probabilities, answer some questions. So let's start taking a look at what some of these problems might look like for us. Oops, went too far. First, if you spun the spinner one time, what is the probability that it would land on a gray piece? Okay, so we have two gray pieces. Okay, so remember we just said that probability is we're going to divide the number of ways it could occur. Okay, so there are only two gray pieces, right? So that's going to be our number on top. Then how many total pieces do we have? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 total pieces. That's our sample space. That's the total number of outcomes that could happen, the possibles. So we want to put 7 on the bottom of our fraction. So the probability that it would land on a gray piece is 2 out of 7. Or if we divided that to get a decimal and get a percentage, sometimes we might want a percentage as our answer. Okay, so 2 out of 7 would be 28.571%. Now, just a reminder, to convert from a decimal to a percent, we move the decimal place over 2 places to the right. So when we divided this, we actually got 0.28571. And so we moved the decimal place over 2 places to get the percentage. Okay. Number 2, if you spun the spinner one time, what's the probability that would land on a white piece? Okay, so we're going to do the same thing. Our total possible outcomes, our number on the bottom is still 7. Okay, but now we want to know the probability that it would land on a white piece. So how many white pieces do we have? We have 1, 2, 3, 4. So 4 out of 7. Okay, as a percentage, what's the percentage there? 4 divided by 7, and then move the decimal 2 places. That would be 57.140%. Okay. And last one on this, if you spun the spinner one time, what's the probability that it would land on either a white piece or a black piece? Okay, so let's think about these. First of all, white or black pieces. How many pieces are either white or black? Okay, that's going to be either, there's 4 white pieces, there's 1 black piece, so that is 5 possibilities out of the 7 total. Let's get that as a percentage. 71.429. Whoops, that does not look like time. Let's fix that. 429%. Okay. Next, let's just take a look. We have an array over here of different shapes, also shaded in or not shaded in. So let's take a look at some of these questions. If you were to select one shape at random from the array, what's the probability that it would be a circle? Okay, so let's find the total number of circles. How many circles do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 circles. And the total number, this is what? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 5 by 5. So we have a total of 25 possibilities. There's 25 things that we're picking from. Only 8 of them are circles. So 8 out of 25, or as a percent, we like these because this is a whole number. This would be 32%. So when we divide it, we get 0.32, which is 32%. All right. So now, next, if you were to select one shape at random from the array, what shape do you have the greatest probability of selecting? So for this one, let's take a look at our different shapes. Circle, we already calculated, we said there's only 8 of those. Okay, we could have a heart. Let's see, how many hearts do we have? 1, 2, 3, 4, 5. Okay, and then what do we have? Square. Okay, let's take a look how many squares we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the greatest probability is when that number on top is going to be the biggest. Okay, so we could get a bigger fraction and bigger, therefore, probability. So the square is going to be the greatest probability because we have the most of those. Okay, so if we're picking one at random, the greatest probability is with selecting a square because there are more of those than any of the other circles or any of the other shapes, excuse me. All right, let's see what else. If one letter is chosen at random from the word combed, what is the probability that the letter chosen will be a D? Okay, well, this is just a simple, let's look at the letters. How many letters do we have? 1, 2, 3, 4, 5, 6. There's 6 letters in total in this word. Okay, how many of those are a D? That would be just 1. So 1 out of 6 would be the probability. We could also get that as a percentage. So that would be, if we divide and then move the decimal over, 16.667%. Okay, so a little over 16% chance that we're going to get D. Number 7, if one letter is chosen at random from the word refuse, what is the probability that the letter chosen will be an E? Okay, so again, let's get the total possibilities. How many letters do we have? 1, 2, 3, 4, 5, 6. 6 again. Okay, how many E's do we have? We have 2 E's. So this would be 2 out of 6, which is, we reduce 1 out of 3, or as a percentage, if we divide, that's 33.3 repeating percent. All right, let's take a look at this last one here. If one letter is chosen at random from the word substitute, what is the probability that the letter chosen will be a T? Okay, so again, let's go ahead and count and get our total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a number out of 10 possible letters, and we want to pick T. So let's see how many T's we have. We have 1, 2, 3. So our probability would be 3 out of 10, or this one's nice. That's easy to convert. That would be 30%. Okay. All right. Next thing that I want to talk to you guys about is an equation that you want to make sure that you write down. Okay. For your or equations, you have 2 different types. So what I'm talking about when I say or equations, I'm talking about if they ask you, what if you get, what's the probability of, choosing something or something else? Okay, so as soon as you see a probability with the word or, you're going to be using one of the following equations. There's 2 different ones. First of all, if your events are what we call mutually exclusive. Okay, so that means that they cannot occur at the same time. So think back to when we did the problem with the spinner. I'm going to go back and show us this one again. So when we did the problem with the spinner here, we actually had an OR equation, and we didn't really know it because we didn't have to worry about both of these happening at the same time. This is what's called mutually exclusive. One of these pieces could not be both a white piece and a black piece at the same time. Okay, they were either white, black, or gray. So we didn't have to worry about these overlapping. Okay, when I say mutually exclusive, it means they cannot occur at the same time. So you can't have both. So when that happens, our OR equation, the probability of A or B, is simply the probability of A plus probability of B. So think back again to that spinner problem. Okay, we'll go back and take a look at it. There were 4 white pieces, right, out of 7, and there was 1 black piece out of 7. So if we add those together, that's where we get our total of 5 out of 7. Okay, that's why that works for the OR equation when they're mutually exclusive. Okay, so we just add the probability of the first one plus the probability of the second one. Now, oops, let's write. Maybe I can write. Okay. When they are not mutually exclusive, we have to account for the things that they have in common. Okay, so this equation looks a little bit different. It's going to start the same. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so we have to subtract the ones that are the same. Okay, so let's start going through some problems, and I'll kind of explain what I mean. Let's say we're talking about a deck of cards, okay? And let's say that I ask you, what's the probability that I choose a 7 or I choose a 3, okay? Those are going to be mutually exclusive because we don't have any cards that are both. We don't have any cards that are both a 3 and a 7, okay? However, let's say that we had a problem where it said, what's the probability of drawing a 7 or a heart? Okay, well, we do have one card that is a 7 and a heart, right? So we would have to subtract that probability away. Okay, so that's what I mean by mutually exclusive, whether or not they can occur at the same time. And that's how you know which equation to use. Okay, so let's start taking a look at some more probability. Number 9, a bag contains 12 red marbles, 10 green marbles, and 2 yellow marbles, 19 blue marbles, and 9 purple marbles. Hopefully I didn't skip any when I was reading through. Find the probability of drawing a green marble. Okay, so here we are going to draw a marble at random, okay? Probability that we draw a green one. Well, we said that there are 10 green ones, so 10 is going to be our top number, right? And then we need to know the total number of marbles. So let's take a look. We've got 12, 10, 2, 19, and 9. So if we add those all up, what is that, 52? Okay, we could reduce that. 10 over 52 would reduce to, if we divide them both by 2, 5 over 26. And then as a percentage, that would be 19.231%. Okay, we'll move the decimal over 2 places. Number 10, we notice we have the same exact situation here. We have the same number. We're in a bag of marbles. We have 12 red, 10 green, 2 yellow, 19 blue, and 9 purple. Find the probability of drawing a red or a non-purple. Okay, so here's where we need to think. This is an OR equation. So, okay, here's what we need to decide. Are these mutually exclusive? So can you have a red marble that is also non-purple? Well, yes, you can. All red marbles are non-purple marbles, right? Okay, so this is kind of a simplistic version so that we can go through when to use that equation. So, okay, probability of A or B. This time we're talking about probability of red or non-purple. So that's going to be equal to the probability of red plus the probability of non-purple minus the probability of red and non-purple. Okay, so this one we probably should be able to figure out pretty easily even without the equation, but I want to go through how to use this equation because there's some where you have to use it. Okay, probability of red. Well, there are how many red ones? There are 12 red ones out of the 52, right? Okay, now we want to figure out our total number of non-purple. Okay, so non-purple, well, that's anything that's not purple. So honestly, what I'm going to do is I'm going to take 52 and I'm going to subtract 9. There's only 9 ones that are purple. So if we subtract 9 away, that leaves 43. And then we want to subtract, I don't know why I put a parentheses there. Oh, goodness. Okay, 43, 52. Now, we want to subtract the probability of red and non-purple. So how many marbles are both red and not purple? Well, all the red ones are red and not purple, so we're going to subtract 12 out of 52. So our total probability for red or non-purple, 43 out of 52. Okay, 43 out of 52. If we turn that into a decimal percentage, move it over 2 spots, that would be 82.692%. Okay, now again, we should be able to probably look at that problem and say, okay, well, there are only 9 purple ones, so red or non-purple is going to be all the rest of the marbles. Okay, but this is an illustration, so we know how to use this problem. How do we use this equation when we get to ones where it's a little bit more complicated? Whew. Let's take a look at working through a deck of cards. Okay. Just so we know, standard card deck has 52 cards. So there are 4 different suits. You have spades, clubs, hearts, diamonds. Okay, spades and clubs are black cards. Hearts and diamonds are red cards. Again, you may know that, so you may be saying, why is she telling me this? But some people don't know that, so I want to make sure that we've talked about it. So now we're going to find the probability. If we draw a card at random from a standard deck of cards, what's the probability that the card is, first, an even number? Okay, so here's what we need to realize. How many do we have that are even numbers? Okay, well, we've got 2, 4, 6, 8, 10. Okay, so that's 5 different cards. And each suit has each of those cards. So there's 4 suits. So 5 times 4, we got 20 cards that are even numbers out of the 52. Okay, if we reduce that, we could divide those by, let's see, 4. Okay, that'd be 5 over 13. Or let's get that as a percentage. So 5 divided by 13 would be 38.462%. Okay, what's the probability that it is a 7? Okay, well, how many 7s do we have? There's 1 7 in each suit, and there's 4 suits. So that's 4 different 7s within the deck of cards, and there are 52 cards. If we reduce that, that's 1 over 13 as the probability, or let's find that as a decimal, 7.692%. We move over 2 places. Okay, a face card. Face cards are jacks, queens, and kings. So there are 3 of those in each suit, and there's 4 suits, so that's 12 cards total out of the 52. As a percentage, or wait a minute, actually, 1 second, we need to reduce that. 12 out of 52, we could reduce by 4, which would be 3 over 13, or now we'll get the percentage, 23.077%. Okay, probability that we would say heart. There are how many hearts? There's 4 suits, so there's 13 hearts. If we divided 52 by 4, so there's 13 out of 52, which is, we just said, there's only 4 suits, so 1/4, which would be an easy percentage, 25%. Okay, A couple more. A king or queen. Okay, so this is an OR equation. But now here's what we need to figure out. Are these mutually exclusive? So can we have a card that is a king and a queen? No, we cannot. So these are mutually exclusive, so we can just add these together. Okay, probability of a king, there's 4 different kings, right? One for each suit. So 4 out of 52 plus how many queens are there? There's 4, one for each suit out of 52. So that gives us 8 out of 52, which would be reduced by, divide each one by 4. That's 2 over 13, or 15.385%. Okay, now let's try this last one. It's another OR equation. Okay, a heart or a queen. So we have to ask ourselves, are these mutually exclusive? Meaning, do we have some that could be a heart and a queen? Yes, we do. Okay, so this is when we're going to use our OR equation. So we need the probability of a heart plus the probability of a queen minus the probability of a heart and a queen. Okay, so let's take a look. Hearts, there are 13. We already found that up here. 13 out of 52 hearts. Okay, queens, we already said the probability of a queen was 4 out of 52. And then we want to subtract the probability of both a heart and a queen. Okay, so there's only one card that's a heart and a queen. That's the Queen of Hearts. So we're going to subtract 1 out of 52 here. Okay, so 13 plus 4 minus 1. 13 plus 4 is 17. Minus 1 is 16 out of 52. Okay, so now we want to reduce, okay, 16 out of 52. If we divide by 2, or not 2, excuse me, if we divide by 4, that's 4 out of 13. 4 out of 13 is going to be, oops, let me move this out of the way for a second, or let's get our percentage, 30.769%. Okay, so that's a very good example of when you have to use that OR equation where you have to subtract the AND portion. Okay, because the probability of a heart or a queen, well, they do have one in common. There's one card that's in common. It's the Queen of Hearts. Okay, so let's take a look again at some more. We're still going to do some more with cards. Okay, now we're going to take it up a notch though. Now we're going to be taking a look at when we're drawing 2 cards without replacement. So without replacement is very important because that changes our denominator, our possible outcomes. If we're not replacing the card back in the deck, then the second time we draw, we only have 53 cards, or excuse me, 51 cards that we're drawing from. Okay, we had 52 for the first draw, and then we're only going to have 51 for the second draw. Okay, so let's take a look. Part A, find the probability that the second card is a heart given that the first is a heart. Okay, so if we're given that the first one is a heart, okay, the first card is a heart, that would be 13 out of 52, right? Okay, the second one being a heart, that leaves 12 cards because we just said that we drew a heart, right, on the first one, and there's only 51 cards left. Okay, when we have an and like this, we're doing 2 different things. We're going to multiply these probabilities. Okay, so if we multiply on the top, we're going to get 156. If we multiply on the bottom, 2652. I'm not even going to reduce this, guys. You don't even have to get this. I'm showing it to you so you know. But you could just type it straight in the calculator. You could type in 13 over 52 times 12 over 51, and it'll give you the decimal. And so let's take a look at what we have as a percentage. Okay, that would be 5 point, oops, make sure I typed that in correctly. Oops. So we got 156 divided by 2652. So that's going to be 5.882%. Okay, as a decimal, that was 0.05882. We turn that into a percent by moving the decimal 2 decimal places. All right, let's try another one. Find the probability that the second card is black given that the first is a spade. Okay, so first is a spade. Let's start with that one. There are 13 cards that are spades. Okay, each suit has 13 cards. 13 cards that are a spade. Now the second one, we want it to be a black card. Well, we just said we drew a spade. That is a black card. So out of the 26 that are black cards, okay, because half the deck are black cards, out of the 26 that are black cards, we just said we drew one on the first draw. So the second one, there should only be 25 left that are black out of 52. Oops, excuse me, out of 51. 25 out of 51. Okay, we multiply that. I'm not even going to write out the fraction for you this time because that's not something that I would ever ask you for. That's a really big fraction. I would not ask you for the fraction or make you reduce it or anything like that. I would just go ahead and ask you either for the decimal or the percent. So that's what we're going to do for this. Okay, we're going to go ahead and multiply 13 divided by 52 times 25 divided by 51. And that will give us 0.12255. So that would be 12.255%. Okay. I usually get in the habit of going several decimal places because you never know what the question is going to ask you, even if it's multiple choice. So I just go ahead and make sure to go several decimal places just so I make sure my answer is going to be accurate. Part C, what are the probability? Find the probability that the two cards you draw are a king and an ace. Okay, so let's think about this. You have 4 cards that are a king out of 52. Okay, next, wait a minute. Oops. Okay, so here's what we want to think about. They didn't tell us which one we had to draw first, right? They didn't tell us that we drew a specific one first. So out of our possibilities, we have 4 that are a king and 4 that are ace. So what that means is we had 8 possibilities for that first draw, right? Okay. Now we're saying that we drew one of those, okay? No matter which one we drew, that leaves 4 for the other one as a possibility, okay? Out of the 51. So we want to multiply these. We want to multiply 8 over 52 times 4 over 51, which would give us, this is going to be a small decimal, 0.01207. So that's going to be 1.207%. So that's a really small percentage chance, right? It's not super likely that we're going to be drawing a king and an ace. Now, I want you to take a look at part D. Notice the difference here. What's the probability that the second card is a king given that the first is an ace? Okay. This one tells us the order that we had to go in, right? With part C, it didn't tell us which card was first. So it was a little bit easier in this case because we knew we had 8 possibilities for that first draw. Okay. Whereas this one, the first card has to be an ace to calculate the probability. So that's only 4 possibilities, right? There's only 4 cards that are an ace. Okay. Whereas before we had 8 possibilities because we didn't know which one was first. They just said the 2 cards you draw are a king and an ace. Now, we want the second one to be a king. So that's 4 cards for that out of 51. Okay, so let's multiply 4 divided by 52 times 4 divided by 51. Okay, this one's going to be an even smaller decimal. It should be half of what we had before. So 0.00603. So notice this one, that's 0.603%. Okay, so that's not even a whole percent of a chance. So that's extremely unlikely. Okay. The thing that I want you to make sure to check out is the differences between those last 2 questions, because at first glance, those 2 questions look extremely similar, don't they? Okay. Both of them are asking about drawing a king and an ace, but part C doesn't give you an order. Okay. So you had 8 possibilities for that first draw and then only 4 for the second draw in order to make it happen. Whereas part D, you had to have the first one be an ace. That's what they asked, given that the first is an ace. So there were only 4 possibilities for that first draw, and there were 4 still for the second draw. okay? So wording is extremely important with these types of problems, paying attention to what they've told you is either a given, noticing if you have an or in the probability they are asking for. We're going to do a lot of practice with this, so make sure that you check through that and ask any questions that you may have.